see. We're going to start a new recording. All right, so the first thing you do is you decide what the GCF is. Now, since this starts with a negative, I'm going to have to take out some kind of negative. 12, 4, and 16, 4 will go into all of those. Then I look at my x's. This person has 2 x's. This person has 1 x. This person does not have any x's. Therefore, it doesn't have that in common. They don't all share that experience. This one has 2 y's. This one has 2 y's. And this one also has 2 y's, so they all share a y squared. So you're going to take it out, negative 4y squared, negative 4y squared, negative 4y squared. And then you're going to put it outside of parentheses, negative 4y squared, and you're going to bring the leftovers down. A negative divided by a negative is a positive, and we're left with x squared. A negative divided by a negative is a positive, and we're just left with x. And a negative divided by a positive, positive divided by negative is a negative 4, and my y's cancel. Now, I'll go ahead and tell you, this one has some more factoring to be done, but we're going to stop on that one for right now. All right, let's try a grouping. I think the number 8 is grouping, so let's try number 8. Number 8. And this is grouping. So try this by grouping. All right, let's look at it. Grouping. If you go to your yellow sheet, it says to group. All right, first thing I need to do is group the first 2, group the last 2. Make sure you put that plus sign in the middle. Second thing it says to do is GCF twice. So the first set of parentheses, my GCF of 5x squared and 5x is 5x. So I'm going to take it out, take out a 5x here, take out a 5x there. I'm going to put it outside of parentheses, and then I'm going to bring my leftovers down. So 5x squared divided by 5x leaves me with an x. 5x divided by 5x is 1. Anything divided by itself is 1. It's not 0. So this is going to be subtract 1. Anything divided by itself is 0. I do the same thing on the other side. This one starts out with a plus, so I'm good. 2xy and 2y share a 2y. I'm going to take it out. That's what I just did. I'm going to put it out of parentheses, and then I'm going to bring my leftovers down. The only thing left over on this term is an x, and 2y divided by 2y is 1. Now, that is not my final answer, but I'm pretty sure that I am correct. The way that I know is that my parentheses match up. So here's the next step for factor by grouping. Take this parentheses out one time. So take it out once, x minus 1. You're going to cross it out twice. So you cross it out here, and you cross it out here. Open that door, please. And then you bring whatever's left over. So here I have a 5x left over. Here I have a 2y left over. Bring it straight down, 5x plus 2y. Now, if you want to check your answer, you would FOIL that. You could make the box, or you could just do first, outer, inner, last. Excuse me. And you would get the correct answer. All right, so that is one, what was the first one? GCF. And then we did a factor by grouping. This is the least common, least used, least important type of factoring. It is one of the types, but it's the least used. It's not something that, I can't say you're never going to use it, but I'm saying it's going to be extremely limited. Extremely limited. All right, let's try to find us a difference of perfect squares. Flip over to the back. Let's do the very last one. It's easy. Number 15. Let's look at this one. Number 15 on the back. This is a difference of perfect squares. This is the last topic that we talked about. Difference of perfect squares. Now, I just gave you a factor sheet, and if you look on the, depends on which way yours is hole punched, but on this page, it tells you your perfect squares. So everything in this column is a perfect square. It's under the square, x squared. So these, it goes all the way up to 625, which is 25 squared. So if it's on this column, this is your perfect square column. If it is on this column, if both of them are on the x squared column, then they are both perfect squares. And since these people are having their differences, you're going to be able to break them up. So let's do that one. Okay, if you look on your perfect square sheet, is 4 on there? Yes. 25? Yes. So these are both perfect squares, and they're definitely having their differences, so we need to break them up. Now, again, when you think about it, it's like a heartbreak. So this one is going to break into 2 parts, and this one's going to break into 2 parts, not 4 parts. A lot of times people will do 2, 2, y, y. That is not correct. So what this is going to break up to is to 2y and 2y, and this is going to break up to 5x and 5x. Now, we're ready for our answer, but order matters. You cannot change the order, okay? So if 2y was first in the situation, 2y has to be first in the answer. So we'll put 2y at the beginning, 5x goes at the back, 5x and 5x. And then when this relationship is over, they're going to have two types of feelings. They're going to have some good feelings for the memories that they made and the fun times that they shared. And then they're going to have some sad feelings for the drama and the hurt and the loss. Now, it doesn't matter the order of the addition and subtraction. So you could have the plus at the back and the subtraction at the front. That doesn't matter. Anybody have any questions on those three types? All right. Let's pause. All right. I know you probably did not finish all of that, but we're going to work on that at the end of class. So I'm going to go ahead and finish our last two types of factoring. There are only two more types. And so we're going to finish these two types up. Then I'm going to put you in a group. I don't know how much time we'll have. But I want to get in groups, and you might not have time. Number 4, sum and difference of cubes. Now, this is extremely confusing. Back to Nathan's question in the beginning, how do you know what you do when you do it? This is confusing because this is feeling a lot like the breakup story sometimes. But this works for sum or difference. But the key thing here is that they have to be cubes. So if you'll go back to that paper that I gave you, mine is purple. Here it is. If you'll go back to this paper, everybody has a paper. It's different colors, but it's cardstock. If it is in the cube column, okay, this is your cube column. If it is in this column, then it's probably a perfect cube problem. If it is not in that column, it is not. So you look for the numbers down that column, and you'll be more familiar with the cubes as we go along. If it's in the cube column, you're good. If it's not, if it's over here, these are squares. This is your square column. So you can't have a cube problem if it's in the square column. Same thing opposite. You can't have a square problem if it's in the cube column. So if it is in the cube column, you probably have a cube. Now, I think it's probably, I'm only going to do one example of this. It's probably best you just put your pencil down and watch me, and then let me give you a minute to catch up with what I did. I can't give you a whole lot of rules. This is something that is a little tricky. So let me just do one example. And like I said, let me write it down, and then you come back and catch up. Let's do one. I'm going to do 27x cubed minus 125. Now, you always start looking for a GCF if possible. We'll see later today where sometimes you have a GCF and something else. For this particular problem, there's nothing that will go into 27 and 125. They don't share anything. This is not the breakup story. Now, a lot of people say, but they're having their differences. Yeah, they are. But this is a cube. This is a cube. The breakup story is only for the difference of perfect squares, and that's not what this is. However, if you go to your cube sheet, we see 27 is a perfect cube, and we see 125 is a perfect cube. Now, let me show you how you use the sheet. You find 27, and you go all the way over to the left, and that tells you that 3 cubed is 27. And then you find 125, and you go all the way to the left, and you find that 5 cubed is 125. So you're going to break it down similarly to what we did in the previous example. So I'm going to split this into 3 parts. It's going to be 3x, 3x, and 3x. You might want to check yourself and make sure you break it down correctly. 3 times 3 is 9, times 3 is 27, and you have 3 x's, so that is correct. Again, it's not 3, 3, 3, x, x, x. That is not correct. It's 3 terms. These are cubes, so we're breaking them down to 3 things. The 125 breaks down to 5, 5, 5. That part's easy. Now, here's where this explanation, I know one time is not going to be enough, okay? Just take some practice. Here's what you do. You're ready to write your answer. Your answer is always going to be a binomial in the front with a trinomial in the back. In other words, 2 terms up here and 3 terms back there. It's always going to be that way. All right. Here's what you do. You take the first term in the front, which is 3x, and you put it at the front. You take the first term in the back, which is 5, and you put it at the back. And that's it for that term. It's a 3x and a 5. It has to be in the order that it was given to you. Okay? All right, let's change colors. Next, you look at the leftovers at the front. So in other words, what was left over up here? Well, I have a 3x left over and a 3x left over. This is where your rules for monomials from last week catch up with you. So 3x times 3x is 9x squared. So the leftovers from the front drop down into the front. Where do you think the leftovers from the back are going to drop down to? The back. So the leftovers from the back, which is 5 and 5, drop down to the back. Now, I already told you that this is going to be a trinomial, and so far we've only got 2 things. So here's how you get that middle term. You go over here to the binomial and multiply this together. So 3x times 5, and you drop it in the middle. 3x times 5 is 15x. Now, that's how, don't write this down yet. I'll give you a minute to write it down. But that's how you get your terms. It's not hard work. It's not a lot of work. It's just, I don't know what it is, nitpicky. Now, your signs, I haven't done any signs yet. Notice I hadn't even looked at it, really. The signs follow SOAP. What that stands for is same, opposite, excuse me, always, and positive. Same, opposite, always, positive. In other words, the first sign is the same as what the problem stated. So what did this problem state? Subtract, right? So the first sign is the same as what you're given. So since I was given a subtract, this one is the same. The next sign is the opposite of what you just did. So if I did a subtraction here, what's the opposite? Addition. So this is addition. And the last sign is always positive. So this is always positive. That never changes. All right, take a couple minutes and see if you can, in your own way, to the best of your ability, with whatever colors and shapes and sizes and arrows you want to do. See if you can make some notes to yourself about what I just did. We're going to be practicing factoring for several days. Probably have a quiz next Thursday on factoring, just factoring, nothing else. Does this class end at 1:15 or 1:30?
1:30.
It starts at 11:15, ends at 1:30. I can't get that straight.
1:15 is whole line. I read it down. I got it down.
You already got it down? Okay. Of all the factoring techniques, this is the one that people, I do not know why. There's no work required. No work required. You just break it down and then drop them in the right places. But you've got to get the pattern down pat. So the first term drops in the first spot, the second term drops in the second spot. The leftovers from the front go at the front, the leftovers at the back go at the back, and then to fill this middle gap in, you come over here and grab these two together. It takes practice. Like I said, we're going to finish these two types, and then we're going to work on that worksheet that you've got with a group. I'm going to put you in groups like random people, and we're going to discuss our question as well when we get in our groups. All right, did y'all get that written down? It works the same exact way if it's an addition. Just watch for your signs. So if this had been an addition, it would have been plus, minus, plus. It's always positive at the end, but the first two signs alternate. Now, good point here. If you wanted to check your answer, you could make a box and distribute this out, and you would get 27x cubed minus 125. Factoring undoes foiling, and foiling undoes factoring. All right, we're going to do two more examples today, and it is do or die. Of all the examples that we've done in factoring, these two are the most important by far. So let's look at what you do when you have a trinomial. So a sum or difference of cubes is only for two terms. Same thing for the difference of perfect squares. That only works for two terms. But if you have three terms, in other words, if you have a trinomial, and it's not a GCF problem, which it may be, but maybe not, then we have this technique for trinomials. All right, number one, you look for a GCF. We will see one today, hopefully before we leave, that has a GCF. But my two examples on this paper are not going to be that complicated. Number two, you make a T chart. That's T as in the letter T. Copy the lead term, put your factors in, and then reduce. It's not that hard. All right, so let's look at an example. Let's start with an easy example, and then we'll do one that's a little bit more complicated. Where's my blue pen? All right, for starters, we'll do x squared minus 5x minus 24. Now, this is something you have absolutely learned. And some of you are going to flash back to 8th or 9th grade and Miss Swatsana and what she taught you. And that's fine if you can remember that far back. But if this does not come to your memory really, really quick within the next 10 minutes, just go ahead and stick with this new technique. But there's other techniques that you may have been taught, okay? So I'm not trying to confuse you. I'm trying to show you something that works all the time, and I think is pretty basic. If you remember what you did in Math 1 or, you know, like I said, 8th or 9th grade, that's fine too. But the first thing I want to do is look for a GCF. Well, this doesn't have a GCF. There's nothing that will go into x squared, 5x, and 24. So next, I just make a T-chart. It literally looks like that. Now, how you fill your T-chart out is a little more involved. What you do is you multiply the first term, which is a 1, times the last term, which is a negative 24, and you put that at the beginning of your chart. Okay, so the first term times the last term goes at the beginning of your chart. This is called a T-chart. The middle term, which is a negative 5, goes on the right-hand side of the T-chart. Do not get those numbers switched up. Some people learn this, particularly I find Richmond County people learn this with the X method or something, star method, something like that. Yeah. You do your chart like this instead of like that. It's basically the same. It just has been tilted. The X method or star method or something. I'm not sure. All right, so what we need to do is we need to find two factors that multiply together to give us a negative 24, and those exact same factors have to add together to give us a negative 5. Now, if you're not quick on your mathematical facts, that's where this sheet comes in handy. So what you can do is look through it and find 24. All right, there's a 24, 6 and 4 right here. I'm trying to get a 5. So 24 would be 6 times 4, but 6 and 4 won't give me a 5. Is that what I'm looking for? 5? Yeah. Here's another 24. 6 and 4, that won't work. Here's a 24. 8 and 3. Would 8 and 3 multiply together to give me a 24 and add together to give me a 5 if I got my signs right? Yes. So my factors are 8 and 3. That's what that's called. Now I just got to get my signs right. So this is going to be a negative 8 times 3 and a negative 8 plus 3. That's going to give me, these are called your factors. These are the factors, negative 8 and positive 3. So in the next step, when it says put your factors in, these are your factors. Your factors come from your T-chart. All right, so I just draw two parentheses, 1, 2. We're almost finished. Once you made your T-chart, you're about done. You're going to copy the lead term. Well, what I mean by that is whatever the problem leads off with, which in this case, it is a 1x squared. So I put 1x squared in the front and 1x squared in the front. I just copy the lead term, whatever it is. Oh, I'm sorry. Drop your parentheses. Don't put your drop your exponent. Don't put your exponent in. You just take the x. I'm sorry. Sorry. That's my fault. Don't take the exponent, just the lead term. Just take the 1x, not the square. Because x squared times x squared would be x to the 4th, and that's not what we want. So you just copy the lead term, which in this case is a 1x. And then you put your factors in. We just found our factors over here in pink. So one of them is going to get a subtract 8. One of them is going to get a plus 3. The order doesn't matter. You can put plus 3 first and subtract 8 second. That's because multiplication is commutative, if you wanted to know why. And then the last step, this is different than a GCF. Reduction is different than a GCF. You just look at both sets of parentheses independently and see if you can reduce. All right, is there anything I can take out of 1x and 8? No. Nothing goes into 1x and 8. What about 1x and 3? No. So that's it. Final answer. You're done. Now, if you wanted to check that, you could FOIL it. You could FOIL it out, first, outer, inner, last. Now, again, it is probably coming back to you. I remember doing this. I remember Miss Johnston taught me this in 8th grade. I remember Mr. Tobias in 9th grade. I remember learning this, and this is a different technique than what I learned way back in the day. This is a new technique I found about 3 or 4 years ago, but I like it. I like it because it works for all types of trinomials. All right, let's try one more over here, and then we're going to practice. So let's go over here to the right, and the last one is going to be 6x squared plus 13x minus 5. 6x squared plus 13x minus 5. All right, number one, you want to look for a GCF. So 6x squared, 13x, and 5. There's nothing that will go into those numbers. 13 and 5 are prime, so you're pretty sure that nothing will go in there. All right, we make our T-chart. Now, where do you get the numbers from the T-chart? This is important because if you have them flip-flop, that's not going to be right. You take the first term, which is 6, times the last term, which is -5, and you multiply them together, and that gives you -30. And then the number in the middle, you got to take the sign, which is a +13, goes over there to the right. This is your multiplication column, and this is your addition column. So you got to find two things that multiply together to give you a -30 and add together to give you a 13. Again, this is where your sheet comes in handy. So we're looking for things that give us 30. Here's something right here. 6 and 5, but 6 and 5 won't give me a 13, so I keep looking. Here's a 30, 6 and 5 again. Here's a 30, 3 and 10. All right, so 3, I got to slide it up a little bit. 3 times 10 is 30, and 3 and 10 will also give me 13. Now, that might not be right because I got to check my signs. Yeah, that'll work if they're, no? Right, because my signs don't work, because this needs to be a negative and that's got to be a positive. So even though 10 and 3 are, they're working, but I can't get my signs right. So it's going to have to be 15 and 2. So 15 times 2 is also 30. Now your signs matter. So 15 has to be positive and 2 has to be negative. 15 times -2 equals -30. 15 minus 2 is 13. So these up here, 15 and -2, these are called my factors. Those are my factors that I just found. And like I said, you may have learned the star method here. There's other options. All right, once you finish your T-chart, just make your 2 parentheses, 1, 2. Now, I messed up on this the first time, and that was my fault. You copy the lead term, but you don't take the exponent. Just do the 6x. So you put 6x in the front of each set of parentheses. That's the lead term. And then at the back, you put your factors. So you just put your factors in. One gets a plus 15. It doesn't matter the order. And one gets a subtract 2. Now, you can't ignore this last rule that I said. You have to check to see if they can be reduced. Reducing is not the same as taking out a GCF. We checked at the very, very beginning to see if there was a GCF, and there was not. So there is no GCF to this problem. But to reduce something, which on that white worksheet, if you look at, let me hold that paper, Nathan. If you look on that white worksheet, number 3, they're just asking you to reduce it by 2. I thought there were 2 of them on here. Yeah, and number 6, they're just asking you to reduce it by 4x. So reducing is not the same as GCF. So let's look at these individually. Is there anything I can reduce 6x and 15 by? Nathan says 3. I agree with him. So we're going to reduce this by 3. And when I reduce it, that's going to leave me with 2x plus 5. That is correct. After I reduce it by 3, in other words, divide this by 3, divide this by 3, that's going to give me 2x plus 5. And then what can I reduce 6x minus 2 by? What will go into 6x and 2? 2. So I'm going to reduce this by 2, reduce by 2. Now, I'm not taking out a GCF. It does not go in the front. It does not go in the outside. It completely vanishes and disintegrates, and you don't see it anymore. So this is going to be 3x minus 1, and this is the final answer. A reduction is not the same as a GCF. A GCF would be taken out in the beginning. A reduction vanishes at the end of your problem. Okay, let's see. Give me just a second. Where's my mouse?